All right, today we're going to pull back the curtain on one of geometry's most elegant and honestly most useful rules. It's a hidden gem that can solve problems that look totally impossible in just a single step. So let's jump right in. So take a look at this. We've got a circle, a triangle just kind of sitting inside it, and this tangent line that just perfectly kisses the edge at one of the triangle's corners. Now, let's say we know the angle between that tangent and one side of the triangle is exactly 56 degrees. The question is, what about the angle all the way over on the other side of the triangle? I mean, at first glance, they seem completely unrelated. So yeah, that's the big question, right? How could you possibly figure out that missing angle without pulling out a protractor? It feels like there's a key piece of information missing, but I promise you, everything you need is already there, hiding in the geometry itself. Okay, so let's treat this like a little detective story, and our first step, naturally, is to investigate the scene. But before we can crack this case wide open, we need to know who we're dealing with. So let's get familiar with the main characters in this geometric mystery. So first up, you've got the tangent. Just think of it like a line that perfectly skims the edge of the circle, right? It only makes contact at one, and only one, point. And then there's our other character, the chord. Super simple. It's just any straight line that connects 2 points on the circle's edge. And this diagram really puts it all into perspective. You can see the tangent just grazing the outside, the chord slicing through the middle, along with, the other usual suspects like the radius and diameter. These are the basic building blocks we're playing with here. Okay, so we've met the characters, we've got our puzzle. Now it's time to reveal the secret weapon, the one rule that connects all these dots. It's called the alternate segment theorem. Now, I know it sounds a little intimidating, but trust me, its real power is in just how simple and elegant it is. So here's what it actually says. The angle between a tangent and a chord is equal to the angle in the alternate segment. So what does that even mean? Well, it just means that our starting angle, that 56-degree one from our puzzle, is always the exact same as the angle formed by that same chord all the way on the other side of the circle. They're like cosmic twins. And this is what I love about this visual. It just makes it so clear, doesn't it? The key idea here is that these two angles, which look totally separate, are actually identical. Always. That outside angle from the tangent, it's a perfect copy of the inside angle at the opposite corner. It doesn't matter how you draw the circle or the triangle, they are just locked together. Okay, but just saying a rule is true isn't really satisfying, right? This is geometry. We need to know why it works. So let's walk through the beautiful logic behind it. Okay, let's break down this proof step by step. It's actually really clever. So step one, the goal is simple, right? We want to prove that our starting angle, let's call it A, is the same as that angle on the far side, YZG. Easy enough? Now, step two is where the magic happens. We just draw one new line, a diameter, starting from our contact point G and going right through the center. That's the key move, because look at what that does in step three. Suddenly, we know two things for sure. We get a 90-degree angle where the tangent meets the radius, that's a classic rule, and we get another 90-degree angle up at point Y, because any angle you draw inside a semicircle is always a right angle. I mean, how cool is that? And that brings us to step four, the big finish. With those two 90-degree angles and the fact that opposite angles in a shape like this have to add up to 180, a little bit of logic shows that angle YZG has to be A. It's just a perfect domino effect. So we've got the rule, we've proved it. Now for the really satisfying part. Let's go back to our original puzzle and see how this theorem just completely demolishes it. And here we go, back to the beginning. The angle between the tangent and the chord was 56 degrees. While the alternate segment theorem tells us that angle is always the same as the one in the alternate segment. So that mystery angle has to be 56 degrees. Boom! That's it. No crazy math, no protractors, just one elegant, powerful rule. Case closed. But here's the thing you really need to remember. This theorem doesn't live on an island. It's a total team player. It's powerful by itself, for sure, but when you start combining it with all the other rules of geometry, stuff about triangles, parallel lines, whatever, that's when you can start solving some seriously complex-looking problems, often in just a couple of moves. And all of this really points to a bigger idea, This theorem isn't just some random trick. It's a perfect example of how beautiful and interconnected all of geometry really is. I mean, look at this. The alternate segment theorem isn't alone. It's part of a whole family of amazing circle theorems. Every single one of them uncovers another one of these secret relationships hiding inside a circle. And when you put them all together, you get this complete, logical system where everything just fits. It really makes you wonder, doesn't it? Geometry is just filled with these hidden connections. So the next time you're looking at what seems like a simple shape, just ask yourself, what other elegant rules are hiding in plain sight, just waiting for us to find them?